morning, everyone. My name is Ali, and my group members are Carol and Laura, and our advisor Armstrong. We are Tax Air, the terminal network team. Here is our agenda. Tax Air is a trucking company, and it's known as a resident truckload company with the specialty of next day service and delivery of all of their regional area, which are almost all of Wisconsin, eastern Minnesota, and northern Illinois, with 6 regional terminals, which are Milwaukee, Chicago, Neenah, Eagan, Eau Claire, and Madison. Milwaukee facility is a headquarter of Tax Air. There is a problem with Tax Air. One of their competitors can run with fewer terminals than what Tax Air has, and Tax Air asked us to reduce their number of terminals instead of 6 to 5 terminals, and decrease the overhead cost of Tax Air and terminals building and fuel cost. Our objective is to increase the income for Tax Air 3 to 5% and decrease the cost for facility from 10 to 15% with fewer terminals, and reduce the overhead cost of physical terminal buildings with meeting some of the design criteria, which are next day delivery to all of the regional area. Drivers must return home at the end of the day because there is a regulation for the driver to be en route for only 10 hours.
Here is our scope. We will develop a constraint model for our project. It will simplify our brainstorming solutions and find the best one, and we will do the judging metric for it. Then we can do the transition process, our estimate process, and loss statement for our project. For our constraints, it's about the schedule for our project, and the assumptions is the points that can make sure our project won't creep. Here is our literature review. We did a lot on that, and we found that there are mainly 4 points on that. First is the mixed entangled programming, and simulation model for the tracking cost. It is a software with a lot of important variables. We are using them into our constraint model. Also, we did some research on the freight facility location selection, and the meeting points and dropping yard may reduce some cost too.
Alright, to solve Tax Air's problem, we are planning to create a constrained optimized programming model. We are chosen a binomial model. This way our decision variable, which is the location of the terminals, will be either open or closed for our selected set of terminal locations. We have 17 possible terminal locations in this model, 11 that we came up with using some of Tax Air's constraints, and 6 that they currently own. Our goal is, of course, the minimization of Tax Air's costs, and from this model we will be calculating transport times and fuel costs directly. We are using Google Earth to find the Cartesian coordinates. I wish I was back there so I could point. Because we will be using Cartesian coordinates, we will be creating an as the crow flies point-to-point direct model. To deal with the fact that roads are not that direct, we will be adding an efficiency factor of 2 to the model. Some of the constraints that Tax Air has asked us to work with are the time from the terminal to the drop-off and delivery area should be 1.5 hours, as well as the distance between terminal and terminal should be no more than 250 miles. Tax Air currently has some methods to get around. There are exceptions to these rules, but these are the goals that they try and aim for. And so we have been asked to do our best to stay within them. We have also been asked to look for only terminal locations that have where did my population one go? That have a population of 10,000 people or more, which is no longer on the slide. The reason for this 10,000 number is so that Tax Air feels they will have a good chance of finding a driver workforce within that county. Because we are reducing the number of terminals, we must have 5 or less terminal locations because they currently have 6. Beyond that, to keep their service at a current state, every current delivery point must be within range of a terminal. Thank you very much. Are there any questions?